So my name's Matt Covalt. I'm a senior R&D engineer with Kitware, and I wanted to talk today about how we implemented the STAC API for an existing web application, and some of the tools that we use to do that. So the web application that we have is an open source geospatial data cataloging platform, and it provides you the ability to perform faceted searches on just a massive amount of geospatial metadata, gives you the tools to partition off the metadata so that certain users can view it and certain users can edit it. And it also bundles in an image tile server. And in the screenshot here, you see this browser UI that we've implemented alongside of it. So why did Kitware want to implement STAC? I think Matt Hansen did an excellent job earlier in this hour describing STAC's strengths. But STAC offers, I'll iterate it here, STAC offers an open standard, and those open standards increase availability and reproducibility of the data, and that results in better scientific collaboration. And these are the things that are very important to Kitware's philosophy. We start to support a bunch of open source scientific projects, so adopting STAC was a no-brainer. The challenge, though, was mapping our current schema to the STAC schema. And our application is built in Django. It uses a relational database for its data models, PostgreSQL. And the data models that we have were custom built for extensible geospatial data types, point clouds, raster imagery, etc. Faceted search, which is very important to our application, and this authorization logic that I previously mentioned. And I don't expect anyone to be able to see this here, but these big maps here that don't equal each other, this is the STAC specification, and this is our Django model. And this isn't an uncommon scenario. Your application-specific view into the data, is designed around sometimes different things than the final product, the final view of it. So there's this idea called Schema Crosswalks. It's super popular in other fields, and it's a reference table. It's printed on a piece of paper, and it says which schema field in one schema maps to another schema. And so we wanted to take this idea with our current application and kind of maintain this readability and this notion of schema crosswalks, but we needed to make it digital, obviously, because it's an API. So we relied on these three tools, which is when we use a bidirectional map. I'll describe it in a second. SQL was a large part of the work, and when we needed to, we used some Python functions. So this bidirectional map is readily invertible, and this is a great example of states to their capitals. You have one-to-one relationship, and it's great because you can go from one data type to the other by nature of the data structure. And this comes really in handy here for the Stackeo extension, where we have this band range that we use in Postgres to index for a faceted search, and then these common names. But it's limited by nature, this bidirectional mapping. So the next tool that we use is SQL. It's perfect for this. It's a single declarative sentence of how our data model maps to the STAC API. And it's active. Awesome, thanks. I've only got a couple slides left, so we should be good. It acts as our source of truth, and it's very readable. And we use Django, so this is expressed via Django's ORM here. And the final steps, we used plain old Python, converting foreign keys to hyperlinks and finalizing the data shape. Yeah, so that's it for this lightning talk. If any of this interests you, please reach out. And of course, our code is open source, and feel free to browse the code on GitHub. All right, thanks.